And it's recording. So 13B, we're going to be looking at finding exact values. Let's have a look at the first one over here. I'm just going to screenshot this one. Your aim is to use your index laws that you currently know to solve this problem. Let's start off with A. 1A, you have 125, and I would say get in the habits of using brackets, so you should be doing brackets all to the power of 2/3. What they want you to do without using a calculator, what is 125 to the power of 2/3? In order to do this problem, this is where you're using what you understand from indices and index laws. Let's break 125. So back in year 7 and 8, you learnt what we called a factor tree. Give me two numbers that you can think of right now that multiplied each other to give you 125.
Just two numbers?
Two numbers.
25 and 5.
25 and 5, very good. 25 times 4 is 100. Most of us know there are 24 25s in 100. So 5 of these 25s, 5 times the 25 will give you 125. That is correct. Now, if you break this further, so this is a prime number. It's a 5. That means I can still look for another number to break down the 25. Give me two numbers, Jordan. Two numbers that multiply to give you 25.
5 and 5.
5 and 5 again. So I now have 5 and 5. Now I've broken it down to its prime factors. The reason why we like it is because 125 is actually broken up into 5 times 5, which is 25, and then times another 5 gives you 125. So by breaking this down, you can say 125 is the same thing as writing 5 times 5 times 5. But using index laws, we know that 5 times 5 times 5 can be rewritten as what? Let's go with Nathan. 5 cubed, very good. So we've got 5 cubed, which is, I'm going to write over here. Notice I'm using the brackets. So I'm putting the brackets in. It's 2/3. This is 5 cubed. So 125 is the same thing as 5 cubed. That's great. We know that now. How are we using our index laws from 13A? What do you do when you have brackets with a power in the inside and the outside? What do you do to the powers? Can I please have, let's go with like hits. What do you do with the powers here?
You times the outside one by the inside power.
Very good. So we multiply the powers. This is rule number 3, if you didn't know. So rule number 1, if you had 5 to the power 3 times 5 to the power 2, same basis, you add the powers. In this case, this is now multiplying the powers, so I'll write the intermediate step so you remember. 3 times 2/3, and the beauty is 3 times 2/3 is equal to what? Let's go with Jem. What's 3 times 2/3? 6 over 3, which is simplified to what? 2. Very good. Okay, and this is what I want you to see, the pattern, and you can see why students generally struggle with these type of exercises because it's got fractions. I would say that I'm training my year 8s to work with fractions because this is one of the things. You see here, 3 times 2/3, this is a divide by 3. So the 3's and the 3's can divide each other. You can say 3 divided over 3 is 1. And so your answer becomes 5 squared. So one of the tips when you're doing these problems, they actually design it in a way that you can always cancel out those denominators. You see all those problems there, when I see a 3 in the denominator, I'm thinking of, can I change that 8 into something cubed? Can I change this 10 into something with the power of 4 or base 4? And then this is to the power of 2, or it has a 2. I'm thinking, how can I change 625 with a something squared, or at least something that cancels with a 2? Okay, those are generally the tips when you're solving this problem here. So once you've done that, now we know this is 5 squared, because that's what we know. 3 times 2/3 is 2. So really, that now becomes 5 squared. And we know 5 squared is 25. So without a calculator, I'm using my index laws from 13A, using algebra, clear layout. I now know the answer, or evaluated the answer, is 25. Okay? Most students should be able to do this, but they don't. Okay, so that type of question there, that's a typical one. Which ones would you generally see in the exam? You might see something like that. You may see something like this. D and E are very typical. Okay, whereas AB, that's your typical, if you flick back to your year 9 and 10 mathematics textbook, generally that's what you'll find. Okay, but here we go. Let's now do another example. I'm going to pick another one just so that you can see how I'd evaluate. Let's do E. Okay, so E just feels a bit scary, but it's not. Let's do it again. E is 10 to the power of 12, all to the power of negative a quarter. Okay, here we go. What's the first thing you're going to do here, Zach? I've got 10 to the power of 2 is equal to, I'll say 10 to the power of 12, all to the power of negative a quarter. What's the first step you're going to do? I'll try.
Good question.
Yeah.
Do you think the answer is I don't know?
I do.
Okay.
And I'm going to then guide you because you didn't know. I'm going to say, what's the rule when you have two powers? Powers on the inside of the brackets and then powers on the outside of the brackets. What would you do, Zach? Yeah, so let's try that. So when you're unsure, use what you currently know. In this case, multiply the powers together. So I'm going to write here 10 to the power of 12 multiplied to negative a quarter. So this is where it's depending on your fractions and how good your algebra is. But hopefully you picked up from what I taught you over here. 3 times, and that's divide 3. So hence 3 divided by 3 is 1. You can actually simplify that fraction of there. 12 times a quarter. What two numbers can I simplify already? Let's go with Jacob.
12 times negative 1 is negative 12, which equals to negative 3.
Very good. Another one is you can see that 12 and 4, they have a common factor of 4. So I can say divide this by 4, divide this by 4. And that becomes 3 over 1. And 3 times negative 1 is then negative 3. Okay, so that's the only part that I can see why students generally find it tricky. Alternatively, yeah, you could do 12 times negative 1 and then divide it by 4. The only problem is when you deal with really large fractions, you've got to know how to simplify. Otherwise, you end up multiplying very large numbers, and that's not what you want to be doing. Okay, so here now we've got 10 to the power of negative 3. Which we know using our index laws, 10 to the power of negative 3, you never leave your answers with a negative power. So changing it to a positive power, would that be, Dylan?
1 over 10 to 3.
Very good. This is rule number 6 from memory. With the negative powers, we can write it as a positive power in the reciprocal. So it's 1 over 10 to the power of 3. But 10 to the power of 3 just means 10 times 10 times 10. So what's 10 to the power of 3 equivalent to? What is it equivalent to? Let's go with Ryan.
1,000.
1,000. Very good. 10 times 10 is 100. 100 times 10 is 1,000. That's your answer. If you wanted to change it to decimals, 1 divided by, or 1 out of 1,000, what is that the same thing as? It's going all the way back to primary school place values. What do we call that? What's this as a decimal?
0.001.
001. Very good. Remember your place values? That's your thousandths place value. So, when you say 0.001, that's the same thing as writing 1 over 1,000. Okay? That's only if you want to change it to decimals. I'm just trying to brush up on your algebra and general knowledge. Okay? But that's how you would do E. D would be exactly the same. But let's try D, just because I know D has a fraction and students don't like fractions. Let's try D. D bracket 1 over 8 to the power of negative a third. So, what do we do now? So in E was easier, because when you don't know what you can do, you can expand the brackets by using the rule, multiply the powers, great. But what about D? D doesn't seem to have a power that I can multiply to. So how am I going to start off with this problem here? Any clues? What are we going to do?
You can cube root the 8.
You can cube root the 8. Very good. Now, that negative, you shouldn't be afraid of the negative. It's the same thing as what you would have done here. You would have done negative a quarter times 12. Well, you have to understand this is still 1 to the power of 1, and this is still 8 to the power of 1. So if you expand it, you can actually do negative a third times the 1 and negative a third times this one as well. That's up to you whether you like it this way. I'll show you how I would have done it. I would have changed that fraction, okay, because if we don't like fractions, I would have used index law number 6 and converted 1/8 into 8 to the power of negative 1. True? Because 1 over 8, using your index laws, you know is the same thing as 8 to the power of negative 1. All to the power of negative a third. True? So all I'm doing is I'm just changing the 1/8. So you had two ways to do that. You can actually multiply the powers using rule number 3, or you can do rule number 6, where I move the 1/8 and I convert it into 8 to the power of negative 1. Okay, so this is currently a positive power, and I convert it to a negative power. Why did I do that? Because now you can use what we were doing before. When you have two powers inside the bracket and outside the bracket, you can multiply the two powers. Negative 1 times negative a third. Change this to positive a third. Okay, now using what you understand, to the power of a third, you can either understand it as cube root, because the power of 1/3 is the same thing as running cube root of 8. But if you didn't know that, you can still solve this using the same technique I showed you in part A. Okay, so part A, you can rewrite, using the brackets again, 8 to the power of a third is the same thing as writing 2 cubed, that's 8, to the power of a third. 2 cubed is 8, all I've done is I've just replaced 8 with 2/3, or 2 to the power of 3. And what you can see here, I can multiply the powers again. 3 times a third, we know that the powers cancel out, so here we go, I'm going to write it 3 times a third, thirds cancel out, so you end up with 2 to the power of 1, which is 2. Okay, but that's what I'm saying, I'm using a lot of different index laws right now. You could have looked at this and said cube root of 8 is 2, you could have done it by breaking down into the factor tree, simplify it again, and you get your answer. There's multiple ways, but regardless, you need to be fluent with this. And that was only question 1. Okay, so that's what 13B starts off with. You need to have those skills with 13A to do 13D, which is solving. All right, let's have a look at another different example. So that was question 1. Let's have a look at how the other questions can get a bit harder. Let's see, we can do, you guys should be fine over here, that's all right. Let's do question 4. So I'm going to do question 4, and then I'll give you some time to do 13B, have a look at the problems, and then I'll show you a typical year 12 question that you can do now, usually worth 3 marks in year 11. Okay, that's in 13D, but I'll show you what it looks like later. Okay, so here we go. Let's do this problem together. Question 4. Let's pick one. Which one of these looks scary?
J.
J?
I thought it looks scary.
I was thinking G.
No, not G.
Not G? All right, J. Let's do J then. Let's do J. So J question is, if you have 256 all to the power of negative 5/8. Okay, notice I like to put in brackets because it makes it easier when you break down the 256. Using our factor tree. This may challenge some of you. 256. What two numbers can you multiply to give you 256?
2 times 2 times 2. 108 times
2 numbers. I just want 2 numbers.
2 and 128.
Good. When you're unsure, just keep halving. It's fine. Keep breaking it down. 2 times 128. Can I break 128 into 2 numbers now?
64 and 2.
64 and 2. 64 is now much easier. 64 is the same thing as?
2 times 2.
Good.
16. 15.
Good. And you can keep halving. Now, if we keep halving, 16 can be broken up to 8 and 2. 8 can be broken up into 4 and 2. 4 and 4. 2 and 2. Now, that's a massive part. And that's what I teach my year 8s. If they don't know, you can keep breaking it down. There are obviously many other factors you could have broken down, and it would have been easier to get to the answer. For example, 64 could have been broken up into 8 and 8, and that would have reduced the amount of sort of steps that you'd have to go down. But let's count the number of 2's that we have here. So 256 is the result of 2 times 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 2. So how many 2's is that? I've got 1, 2, 3, 4, 5, 6, 7, 8. So I know 2 to the power of 8 is the same thing as 256. Okay, this is called a factor tree technique. So why do I want to know that? Because 256 now can be written as 2 to the power of 8, and it's all to the power of negative 5/8. See what I mean? The questions are designed so that when you multiply it, the denominator and the power are going to cancel out. So you can see here, 2 to the power of 8 times negative 5/8. So using that rule number 3. When you multiply them, you can see that, sorry, that's not 8. That should be 8 there. These should cancel out. 8 divided by 8 is 1. And then you now end up with 2 to the power of negative 5. Never leave your answers in negative powers. Should always change it to positive power. So what is 2 to the power of negative 5 the same as? How do I write it as a positive power? I know what negative. Very good. Reciprocal, and then write it as a positive power. That's rule number 5, or rule number 6, sorry. That's your negative powers index law. So I'm using all the index laws here. And because they said evaluate, you can't just leave your answer as 1 over 2 to the power 5. You do need to figure out what 2 to the power 5 is. Count with your fingers. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 again, so that's 5 times now. That's 32. Okay, so I know the answer is 1 over 32. And that's exercise 13B. Okay, so 13B, you can see I'm still using my index laws. What's tricky? It's the fractions, the negatives, and the square roots, the thirds. So knowing cube root is the same thing as 1/3, square root is the same thing as power of half, fourth root is the same thing as power of a quarter. Those skills are very common mistakes. So in the year 12 examiners' reports, that's all they ever talk about. They talk about the number of kids in Australia, not just Victoria, that don't know their fractions, their index laws, their algebra in general. That's common. So if you're finding that difficult, what I'm explaining seems intimidating, that's what the state is. So all you have to do, brush up on those skills, and you're already ahead of the state. Doesn't take a lot to do that. Okay, so it's just brushing up on your junior mathematics from 7 to 10, then you'll find that as you move forward, it's much easier. So it's not the content that I'm going to teach, it's your algebra. Can you deliver is where the difference between each and every one of you is sitting at. It's not the theory about what the graphs look like, it's can you solve. And most of you will struggle there. Okay, so there we go. I'm going to leave you with exercise 13B for now, and then we're going to reconvene and look at one of the examples. For those who want to go ahead and look at 13D, a typical year 12 question comes from here. Year 12s will need to know, they will have only one exercise with only one question that deals with this type of problem. You can have a look at that one if you want. So question 4, that's a very typical year 12 question. Often it's 3 marks because you end up with 2 possible answers, one of which you have to reject. I'm not sure if they're going to make you reject one of the solutions here, but usually you should have one that you would need to reject and you need to justify why. That's why it's a 3 marker. It's an exam 1 question. No calculator allowed. If you like, you can have a go with that, but that's what I'm going to go through in the second half. Okay, so around maybe 1:05, you've got about 20 minutes. 1:05, I'll go through example 4, just so you have a better idea of how would you solve question 4. Okay, I'm going to stop the video here.